right, next up is another thing about fundamental frequencies on that are resonant in musical instruments. So now instead of a string, we have an organ pipe that's open on both ends, and we've got that it's 26 centimeters long. And we are trying to figure out the fundamental frequency and then the first three overtones. So for a open tube, the formula is that the fundamental frequency will be V over 2L. This is identical to what it was for the string that we just did in the previous problem. Same equation. So open tubes and strings behave in the same way. The speed of sound is not given here, and I don't believe it's on the equation sheet either. So yeah, it's not on the equation sheet either. Mostly because the speed of sound varies. So if you were doing this on your own, you'd probably have to look that up in a book. But if this was on the test, then I would give you that equation, give you the speed of sound in air. But here I'll write down that it's 343 meters per second. Certainly if you found a little bit different value, that's probably would be fine. The organ pipe is 26 centimeters long, so it's 2 times 6 meters. Plug that in. And I get 659.6 hertz. And I'll round that to 2 sig figs, so that's 660 hertz. All right, so this is just a typical wave on so all of the overtones will be integer multiples of that. So the next overtones are just n times whatever the initial one was. So for n equals 2, that would be the first overtone. Would have 1320. For n equals 3, we'd have 1980. And for n equals 4, we have 2640. First three overtones are just those written down. $13.20, $19.80, and $26.40. Could certainly round those to 2 sig figs to be most appropriate there as well. All right, next is a tuner. I think this was a question pulled from your most recent midterm. Has a tuning fork, and the tuner has a beat frequency of 2 hertz. What's the frequency of the instrument? Well, I know that the beat frequency is the difference between the two individual component frequencies. One of these is 554 hertz, and that is 2 hertz. So I know that 554 minus whatever this number has to equal 2 when I take the absolute value. So this number has to be either greater than 554 by 2 or less than 554 by 2. So it is that right there. So you can't distinguish between the two of these unless you have some more information. And we had a couple of problems where you could distinguish between these just based on having had more information than we did in class. This is just as simple as this question can get. So you can have either one. And then our last in the sound and waves review is which one has a longer wavelength. A 400 hertz sound wave or a 400 hertz 400 hertz sound wave in air or in water. And so we're looking again with the V equals wavelength times frequency equation. And we are looking for the one with a longer wavelength, so we'll solve for it. So lambda is going to be V over S. And the frequency is the thing that doesn't change, right? As a wave passes from one medium to another, it doesn't matter if it's sound, if it's electromagnetic, if it's any wave, a wave on a string, as it passes from one to the other, that has to stay the same. The frequency doesn't change. But the speed of this wave most certainly does. So the speed of the wave is going to be faster as you move to more dense mediums. So this is bigger for water. And because this is bigger for water, that will be bigger for water as well. So the correct answer there is B.